So today's topic is Maxwell-Boltzmann distribution law for speed. So let us put the heading Maxwell-Boltzmann distribution law of speed. So we are discussing the speed of molecules in a gas, and we know that Maxwell-Boltzmann distribution, in short, which is written as MB distribution, this comes in classical statistics. It is part of the classical statistics. Classical statistical mechanics. So we already have the Boltzmann canonical distribution law, and we will use that law, canonical distribution law. Canonical distribution law. And this law states that Ni is equal to A gi e to the power minus beta ei. So here A is constant. And gi is the priori probability. And it is the number of cells with energy ei. So gi, number of cells, makes a zone of gi cells with energy ei. So gi means we have to calculate the number of cells. So now come again to this equation. So here Ni means it is the number of molecules having the speed or having the energy ei. So let us first calculate the value of gi, which represents the number of cells. So it will be the total volume of the phase space. And then this divided by the volume of one cell. Now the total volume of phase space means we have to integrate 6 times integration over dx, dy, dz, and then dpx, dpy, and dpz, and divided by the volume of one cell, and volume of one cell is h cube. Now if we integrate this function, then 3 integration over dx, dy, and dz, this will give the ordinary volume. And then we are left with the 3 integration over dpx, dpy, dpz, and this whole divided by the h cube. So this volume will represent the annular volume between two spheres, such that the radius of the inner sphere is P and the radius of the outer sphere is P plus dP. And we have to calculate the volume of the shaded region. That is the momentum between P and P plus dP. So this we can calculate as the volume of the shaded region will be this is the volume of the outer sphere minus volume of the inner sphere. So let us write it 4 pi by 3, and then it will be P plus dP whole cube minus P cube. So 4 pi by 3 P plus dP whole cube will represent the volume of the outer sphere, and the 4 pi by 3 P cube will represent the volume of the inner sphere. So let us expand the bracket, and then we will have the P cube plus dP cube, and then plus 3P square dP plus 3P dP square, and then minus P cube, this minus P cube. So this P cube gets cancelled with this P cube, and we have the term dP cube and then dP square. Because the dP is very small quantity, therefore dP square and dP cube will be even more small, and we can neglect these two terms. So we are left with 4 pi by 3, and then we have the term 3P square dP into 3P square dP. So this 3 and 3 also gets cancelled, and then we have 4 pi P square dP. So the value of this integration is V into 4 pi P square dP upon H cube. We can directly write the 4 pi P square dP as the surface area of the inner sphere. 4 pi P square represents the surface area of the inner sphere, and then the thickness dP. So directly we can also write it as 4 pi P square dP. So we have this value of the GI. Now we will substitute this value of GI in the equation, in this distribution function. So let us put 4 pi V P square dP upon H cube, and let us go to a new page. So we have Ni is equal to A, and then GI is it is 4 pi V P square dP, and then divided by H cube, e to the power minus beta EI. So this is the distribution function. Now we are interested in finding the distribution function of the speed. So we will write this distribution function in terms of the speed. So now we will write it as NV dV is equal to 4 pi AV upon H cube, and then P square dP e to the power minus beta EI. So because we are interested in finding out the speed, therefore we will substitute velocity instead of momentum. So we will put the value of momentum in terms of the velocity. So it will become 4 pi AV upon H cube, and then P square. So P is equal to m into V, or dP is equal to m into dV. So let us substitute this value. So P square means it will be m square V square, and dP means it will be m into dV, and then e to the power minus EI. EI is the kinetic energy. So kinetic energy is half mv square. So it is mv square upon, and beta is equal to 1 upon kT. So e to the power minus mv square upon 2 kt. 2 kt. So this will become 4 pi a v by h cube into m cube and then we have v square e to the power minus mv square upon 2 kt into dv, and this is the value of nv dv. So nv dv represents the number of molecules having speed between v and v plus dv, having speed between v and v plus dv. So this is the number of molecules or the distribution function for the speed. Now all these factors are constant, so let us put another term b. All these are equivalent to another constant b into v square e to the power minus mv square upon 2 kt into dv. This is the speed distribution function nv dv. Now to calculate the constant b, we will integrate this within the limit. We will integrate this within the limit 0 to infinity. So put another heading, evaluation of constant b. So for this we will integrate both sides within the limit 0 to infinity. nv dv is equal to constant b and then 0 to infinity v square e to the power minus mv square upon 2 kt dv. Now this nv dv means all the particles having different velocity, different speed within the limit 0 to infinity. We are calculating here speed, therefore the limit is 0 to infinity, and so this will become the total number of the molecules, which is capital N. So capital N is equal to b, and then we have this function, the integration 0 to infinity v square e to the power minus mv square 2 kt into dv. So to calculate this we will use the standard integration, and that standard integration is 0 to infinity x square e to the power minus alpha x square dx. This value is 1 by 4 under root pi upon alpha cube. This is the standard integration, and we will use this integration and put the value directly. So n is equal to b, where n is the total number of the molecules in the system, and then this value is 1 by 4 and under root pi, and then alpha is m upon 2 kt. So because alpha is in the denominator, so it will become 2 kt upon m to the power 3. This is the value. Now we can do some manipulation here. We will write here pi in numerator and denominator also. So the numerator will become 2 pi kt whole cube, and in denominator it will be pi cube. So pi cube will come outside of the bracket. Pi will come outside of this bracket. So here we will have pi upon pi cube, and so we will have 1 upon pi square. Pi upon pi cube means 1 upon pi square. So let us write it here. N is equal to b 1 by 4 and then under root 2 pi kt upon m and this whole cube, and then 1 upon pi square. So 1 by pi square will come outside and it will become 1 upon pi. So in this way we have value of b, and value of b will be 4 pi n m upon 2 pi kt to the power 3 by 2. So this is the value of the constant b. Now we can substitute this value here. So it will become nv dv is equal to 4 pi capital N into m upon 2 pi kt 2 pi kt to the power 3 by 2, and then we have v square e to the power minus mv square upon 2 kt into dv. So NV/dV means it is the number of molecules having speed between v and v plus dv, and this is given by, this is the distribution function given by this expression. Now we will use this expression further. So let us go to the next page. And let us write again the function. So it is NV dV is equal to 4 pi n into m upon 2 pi kt to the power 3 by 2, and then v square e to the power minus mv square upon 2 kt into dv. So this is our distribution function. This is our master distribution function. So in this function we see that there are two terms containing the velocity, speed, containing the speed. So the first term is this, second term is this. So at lower speed, this second term will become like e to the power 0, that is 1, and therefore this term v square will be effective term. It means that the number of molecules will increase with the speed. So NV dV will be proportional to v square at lower speed, and at higher speed, this second term will be like e to the power minus infinity. E to the power minus infinity means it will be like 0. It means that NV dV will tend to 0 value. So, and also at v is equal to 0, at 0 velocity. So let us write one more condition. At 0 speed, not velocity, it is the speed. At 0 speed, NV dV is 0. It means that it is rising from 0 with the proportionality of v square, and again it is going to the 0 with exponential decay. So if we plot a curve between NV and V, NV means the number of molecules having the speed v, and here it is the speed. Then we have the function like this. Means at v is equal to 0, when the speed is 0, then the number of molecules is 0, and as the v increases, then it increases as v square, and then again it decreases as the exponential term. So this is the distribution function, a distribution curve, and if we want to calculate the number of molecules at a particular speed v, then suppose this is the speed v1, then we will have this much number of the molecules, and then NV dV is represented by this shaded region, where the first line corresponds to speed v, and the second line corresponds to speed v plus dv. So this shaded region represents the NV dv, that is the number of molecules having speed between v and v plus dv. So this is the distribution curve. Now let us see the dependence of NV dv on temperature. So here we can see that if we increase the temperature, then NV dv will decrease. So let us draw another curve showing the dependence of the NV dv on the temperature. So here again on the y-axis we have NV, and on the x-axis we have the speed, and now I will plot three curves at different temperature. So this is the temperature T1, and this is the temperature T2, and this is the temperature T3. and here T1 is less than T2 and which is less than T3, because at the higher temperature, the number of molecules is less in comparison to the lower temperature. So this is the curve representing a graphical method to represent the distribution function. Now suppose if you get in question about the distribution like NP or NPDP, then what is the meaning of NP and NPDP? And you can also find NE and then NEDE. So this NP represents the number of molecules having the momentum P, and NPDP means number of molecules having the momentum between P and P plus dP. Similarly, NE means the number of molecules having energy E. NEDE means number of molecules having energy between E and E plus DE. So because we have the distribution function in terms of the velocity, so using this distribution function we can derive the distribution function NPDP and NEDE and also NP and NE. What we will do, we will substitute the V terms in terms of the momentum or in terms of the energy, because we know that P is equal to m into V, so velocity is equal to P by m. So in this equation, wherever it is velocity term, we will write the velocity in terms of the momentum, and also we will replace dV as 1 by m into dP. So we have to replace this V and also this dV. In a similar way, we know that energy is equal to half mv square, and therefore velocity is equal to 2e by m to the power half or under root, or we can write it as dE is equal to half m into 2v dV. So using these relations we can replace the velocity in terms of the energy E and dE. In this way we can have the distribution function in terms of the momentum or in terms of the energy or in terms of the velocity. So this is our master distribution function. And we will use this distribution function for calculating the speed. And now we will calculate the most probable speed and then average speed and then root mean square speed. So let us go to the next page, and then we will calculate the various types of speed, and we will again rewrite this function. So let us go to a new page and write the function again. So it is NV dV is equal to 4 pi n, and then it is m upon 2 pi kt to the power 3 by 2, and then v square e to the power minus mv square upon 2 kt into dV. So this is our distribution function, and now we will calculate the most probable speed. So let us calculate most probable speed, which is V most probable. So most probable speed means that speed which is possessed by a large number of the largest number of the molecules. So that speed is known as the most probable speed. So let us come again to the distribution curve which I have drawn in the previous page. So this is the shape of the distribution function, and this speed is possessed by the largest number of the molecules, and therefore this speed is known as the VMP. This speed is the VMP, most probable speed. And the method is very straightforward. We know that if we want to calculate the maxima or minima of any function, then we first find the first derivative and then put that derivative to 0. Means we will calculate dnv upon dv, the first derivative dnv upon dv, and we will put this equal to 0, and this will give the condition. So let us do that. Means we have to find out the first derivative of this function. So it will be 4 pi n and then m upon 2 pi kt to the power 3 by 2 and then v square e to the power minus mv. Oh, I am writing it again. So let us do this and then I will write the derivation in the next step. So it will be again this all these constants and then the derivation. So this is the product of the two function, the first function is this and this is the second function. So we will apply that formula. So the first function and then differential coefficient of the second function, so it will be e to the power minus mv square upon 2kt, and then differential coefficient of this term, and that will be minus v square means 2v, so it is 2mv upon 2kt, and then this second function and the differential coefficient of the first function, which is 2v, and this is equal to 0, because we have to find out the condition for the most probable speed, and therefore we will put the first differential coefficient equal to 0. Now we can take this factor outside the bracket because this factor is a common factor in both the term. So we have this constant term and then this exponential term, and inside the bracket we have v square and then minus this 2 and 2 get cancelled, and then we have minus mv upon kt and then plus 2v. This is equal to 0. So if we put all these terms on the other hand, then this will become 0 and we are left with this v and v will also get cancelled, and then we have only minus mv square by kt and then minus 2 will go on other side, so this will be minus 2, so minus again get cancelled, and then we have v square is equal to 2 kt upon m, or v most probable is equal to under root 2 kt upon m. So this is the value for the most probable speed. Under root 2 kt by m. So now let us go for the another exercise, which is the calculation of the average speed. So again we will use the same function. So go to another page and again write the same function, because we will need it again and again. So it is nv dv is equal to 4 pi n then m upon 2 pi kt to the power 3 by 2 and then v square e to the power minus mv square upon 2 kt and dv. So this is our distribution function for the speed. Now we have to find out the average speed. And we know that for the average speed we can write the formula as summation over I ni vi and divided by summation over I ni. It means that it is the speed of all the molecules and divided by the number of molecules. So here we will replace the summation by the integration, and therefore it will become the integration from 0 to infinity and then v and the value of ni which is 4 pi n into m upon 2 pi kt to the power 3 by 2 v square e to the power minus mv square upon 2 kt into dv. And then this whole divided by integration within the limit 0 to infinity nv dv. So this integration will give the total number of the molecules n. So this is equivalent to n, capital N, and this capital N will get cancelled with this capital N, and therefore now we can take all these constants outside the integration. So 4 pi and then n is cancelled with this n, and therefore 4 pi and then m upon 2 pi kt to the power 3 by 2, and the integration 0 to infinity, then this v and this v square means it is the v cube e to the power minus mv square upon 2 kt into dv. So now here again we will use a standard integration, and that standard integration is 0 to infinity x cube e to the power minus alpha x square dx is equal to half into 1 upon alpha square, So let us substitute this value. So it will be 4 pi and then m upon 2 pi kt to the power 3 by 2, and then this value. So this is half and then 1 upon alpha square. So alpha is m upon 2 kt, and because alpha is in denominator, therefore it will become 2 kt divided by m into whole square. So this 2 and 2, 4 is cancelled, and then to solve this, what I will do, that put all these items into the square root. So this 2 pi means 4 pi square, and then this factor will be m cube divided by 8 pi cube, k cube and t cube, and then multiplied by all these, because this term is a square term, so in the square root this will become 4 times. So expand this, it will be 16 k to the power 4 t to the power 4 and divided by m to the power 4. So this 4 2 ja 8 and this 2 8 ja 16, and then pi square and pi cube. So this pi square and pi cube, and we are left with only pi in the denominator. Then m cube upon k cube t cube, and here it is k to the power 4 t to the power 4 and m4. So this will also cancel, and then we have the term 8 kt upon pi m. So this is the leftover term, that the average speed is equal to under root 8 kt upon pi m. So this is the value which we wanted to calculate for the average speed. Now go to the next page, and then we will calculate the root mean square speed. So again let us write the same distribution function. nv dv is equal to 4 pi capital N, and then it is m upon 2 pi kt to the power 3 by 2, and then v square e to the power minus mv square upon 2 kt into dv. And now we have to find out the root mean square speed. And in short it is written as VRMS. So what does it mean by root mean square speed? So first we have to calculate the square speed, means the v square, and then mean square speed means we will take the average of the v square, and then the root means we will take the square root of this. So it is the reverse process, the square of the speed, then the mean of the square of the speed, and then root of the mean of the square speed. So it is known as the root mean square speed or VRMS. So what we will do, first we will find out the V square average of the V square, that is mean square speed. So this will be evaluated using the same formula, that is summation over I Ni and V square, and this whole divided by summation over I Ni, and this summation over I Ni represents the total number of the molecules. So instead of the summation we will use the integration sign, so it will become integration within the limit 0 to infinity and then V square and then value of Ni, which is 4 pi n and m upon 2 pi kt to the power 3 by 2 and then V square and e to the power minus mv square upon 2 kt into dv and then this whole divided by integration within 0 to infinity nv dv and this will give the total number of molecules, that is capital N. So this capital N will get cancelled with this capital N. So we are left with the constants 4 pi and then m upon 2 pi kt to the power 3 by 2 and then within the integration it is 0 to infinity v square and then v square means v to the power 4 and then e to the power minus mv square upon 2 kt into dv. So to calculate this integration we will again use the standard value. So standard value is 0 to infinity x to the power 4 e to the power minus alpha x square dx is equal to 3 by 8 under root pi by alpha to the power 5. So we will use this standard value here and we have 4 pi then m upon 2 pi kt to the power 3 by 2 and now it is 3 by 8 and then under root pi and then alpha is m upon 2 kt and because alpha is in denominator therefore it will become 2 kt upon m to the power 5. So this 4 2 ja 8 here and then again to solve this let us put all the items inside the square root. So this pi square and then m cube divided by 8 pi cube k cube t cube into 3 by 2 means 9 by 4 and then this pi and then this to the power 5. So open this bracket and this will become 32 k to the power 5 t to the power 5 divided by m to the power 5. So let us calculate this. Now we have pi square and pi means pi cube. So this will get cancelled with this pi cube. And then this 8 4 ja 32 and 32. So and here it is the m by kt power 3 and here it is kt by m to the power 5. So now we have 9 and then k square t square upon m square or this is equal to 3 kt upon m. So 3 kt by m represents the term v square bar. We have calculated here v square bar but our actual result is under root v square bar. So under root v square bar which is VRMS root mean square speed, this will be under root 3 kt by m, under root 3 kt upon m. So this is the final result. So we have calculated first we derived the Maxwell-Boltzmann distribution law for the speed, and then we, using this distribution function, we have calculated the most probable speed, then the average speed, and then the root mean square speed. So let us go to the next page and compare all these three speeds. So we have most probable speed, and then we have the average speed, and then we have the root mean square, speed, So most probable speed can be denoted by VMP, and then average speed means it is V bar, and then root mean square speed means it is VRMS, and actually it is under root V square bar, and the value is here, it is 2 kT by m to the power half, under root 2 kT by m, or it is 2 kT by m to the power half, and here it is 8 kT by pi m to the power half, and it is 3 kT by m to the power half. So if we compare these, then this term kT by m is common, this kT by m and kT by m, and the different term is here 2, and then here it is 8 by pi, and here it is 3. Now the value of 8 by pi will be, pi is 3.14, so it will be between 2 and 3. This value is between 2 and 3, and here it is 2 and here it is 3. So 3 is greater than this and this is greater than 2. It means that root mean square speed, VRMS, is more than average speed, and this is more than the most probable speed. So this is the relation. Between the three speed, and this is all about the today's lecture. So let us stop here.